One way to control traffic into or out of a network, or even into and out of an individual device, is by configuring a firewall. Firewalls come in a couple of different forms. You could have a hardware appliance, a physical device that you connect to your network that can be configured with firewall rules to control network traffic flow. Or you could have a virtual machine appliance that's designed to act as a firewall. It could be a host-based firewall like Windows Defender, which is included with the Windows operating system automatically. So we're really saying it can be hardware or software-based. Now the firewall can be configured with rules that either allow or deny traffic that's coming into or leaving something, like a network or an individual host. Now it consists of rules which are called Access Control List or ACL rules. And they can look at things like IPv4 and IPv6 addresses and much more, which we'll talk about right now. Let's start by talking about a packet filtering firewall. This applies to OSI Layer 4. Now, if you think back to when Mike talked about the OSI model, Layer 4 is the transport layer. And the protocols that would map to that would be things like TCP and UDP, and the addresses that map to Layer 4, the transport layer, are things like port numbers, such as a web server with HTTPS listening on port 443. So when we say that we have a Layer 4 firewall, if we know what Layer 4 means, we know what it can do. What does that mean? It means it can look at port numbers and other things like IP addresses. Now we can have a stateful or a stateless packet filtering firewall. A stateful firewall is one that instead of looking at each individual packet independently, it does that, but in addition, it tracks entire sessions. If you think about TCP versus UDP, UDP doesn't use sessions. It's one packet at a time. There's no guarantee that it was sent, and we're not checking if it was received. We don't care. It's best effort. TCP is the opposite. It uses a session-based type of communication paradigm. And so a firewall can look at TCP sessions for their entire duration, as opposed to only looking at individual packets. So the rules that we build for a packet filtering firewall can be based on things related to Layer 4. We know that that means port numbers for a service, but also things in Layer 3, IP addresses, things in Layer 2, MAC addresses. You can also look at the type of protocol for the transmission, whether it's TCP, UDP, perhaps ICMP, for example, maybe it's ping traffic. So let's take a look at how we might configure an OSI Layer 4 packet filtering firewall in the cloud. Here in the Microsoft Azure portal, I've signed in and I'm going to click Create a Resource in the upper left. What we're going to create is what's called a Network Security Group, otherwise shortened down to an NSG. A Network Security Group is a collection of firewall rules that we can associate either with individual virtual machine interfaces or with an entire subnet. Of course, those would be in the cloud. So I'm going to click Create, and we're going to have to fill out some details to create this network security group. I'm going to deploy this into what's called a resource group. A resource group is just used to organize related cloud resources. I already have one here called Project X, and I'm going to call this network security group Linux Allow. So it's going to have some firewall rules to allow Linux-based type of traffic. And I'll deploy that in Canada East. So I'll click Next for tags. I'm not going to add tag information, so Next, Review and Create. And I'll just click the Create button. So of course, all we've configured is the object. We haven't yet configured any firewall rules within it, but that's going to happen right away as soon as it's deployed. So I'm going to click Go to Resource to open up that network security group. So now we're in our Linux Allow network security group properties. Over on the left, I'm going to click Inbound Security Rules. There are 3 default inbound security rules to allow traffic from other cloud-based virtual networks, to allow traffic from a cloud-based load balancer. Other than that, anything else trying to come in through this network security group is going to be denied, as we can see in the rightmost column. I can hide those default rules if I don't want to see them, but they're always active, even if they're not displayed. Same is true for outbound security rules in the sense that we've got some default rules to allow traffic out. Basically, anything in the cloud in this particular case that is affected by this network security group, outbound traffic to the internet will be allowed unless I change the default rules to do something else. So I'm going to go to inbound rules because I want to allow remote Linux management over SSH, Secure Shell. Secure Shell uses TCP port number 22. So of course that's layer 4 OSI model transport layer. It's a port address. So what I'm going to do here is click the add button up at the top because I want to add a security rule to this firewall ACL list. Now where do I want to allow this traffic to originate from? I could specify an IP address, or I might, for instance, just leave it on any. So anywhere that this is sourced from, I want to allow the connection in. The source port range, well, I'm not really concerned about the source port range on a connecting client. I'm really more interested in the destination port because that way I know they're connecting to SSH, right? Port 22. So the destination, again, I could specify the individual hosts I want to allow the connection to, but I want it to go to any of my Linux virtual machines, so I'll leave it on any. For the service, I can even choose SSH, it's such a common thing, from the drop-down list. And what it did is it set it to TCP port 22, because that's what SSH uses. Well, that was easy. Down below, do you want to allow or deny it? We want to allow that type of traffic coming in. We can then assign a priority number. Now, what's that do? Well, it's a priority list that determines which rules are processed before others. For example, a firewall rule with a priority of 100 is checked before a firewall rule with a priority of 101. So when traffic is coming in, it's going to be matched against our rule with a priority of 100. And if the traffic matches this firewall rule, then the rule will apply and no further rules will be checked. And that's why it's important to think about the ordering with these priority numbers. We have to give a name to this. I'm going to call it allow inbound SSH, and of course it tells me that you can't have spaces in the name. Okay, well that's fine. Now we can click add to add that. So now we have our item, our rule, added to this network security group, allow inbound SSH. Now to finish this up, this example, over on the left, we have to assign this to something. It's not yet assigned or effective. So over on the left, we can click Network Interfaces, and we can add virtual machine network interfaces here that we want to associate this network security group with, or we can choose an entire subnet. By associating a network security group with an entire subnet, it applies to all of the virtual machines deployed into that subnet. We can also use content or URL filtering firewalls. These apply all the way to the top of the OSI model, layer 7, the application layer. Now the rules that we build for this type of a firewall can be based on the direction of the traffic. Is it incoming or outgoing? And then the same type of thing that we see with layer 4 packet filtering firewalls, source and destination IP addresses, source and destination port numbers, protocol types like TCP, UDP, ICMP. But this is where it gets different. Then it can look at very protocol specific items like HTTP details, like whether we're reading HTML pages or posting something to a website. It can look at the URL to see what people typed in. It can even look at the packet payload, anything that is supplied as actual data, to make a decision as to whether to allow or deny the traffic. Now, if we look at a packet and break down the headers and apply it to the OSI model, and really in the end apply it to firewalls, when we break down a packet, it has an Ethernet header. That's got the source and destination MAC address. That's layer 2 of the OSI model. So if we have a layer 2 firewall, it can really only allow or deny based on MAC addresses. Next, we have the IP header, layer 3 of the OSI model. That's the network layer. And that would deal with things like source and destination IP addresses. Then we have, in this case, it really depends on the transmission, but in this case it would be either TCP or a UDP header. If you're hitting a website, it's TCP. If you're doing a DNS query, it's UDP. Either way, TCP or UDP uses port numbers. This is layer 4 of the OSI model, the transport layer. Then we have things that are specific to the protocol, like HTTP or DNS and so on. And that would apply to layers 5, 6, and 7 of the OSI model. So why is this relevant? Well, we want to make sure that a packet filtering firewall, for example, applies to layer 4, that we have an understanding of what that means, and that when someone says, well, this security solution is layer 7, we need to understand what that means. It's much more sophisticated than a layer 4 type of solution, for example. Now, when it comes to web applications, there are very specifically crafted malicious type of attacks that we can protect against using a web application firewall, a WAF. And again, this applies to layer 7 of the OSI model. It's very specific to HTTP. So it protects against common web application attacks, things like cross-site scripting attacks. This is where a malicious user can inject executable script code into a website that's viewed by others, and the others would execute that code on their browsers. Or it could be some kind of a cryptographic downgrade attack to make sure the server dumbs down to something that we know has security vulnerabilities. Or directory traversal, where through the web app, people are able to navigate the file system that web app is running on. Or even SQL injection attacks, where people can essentially formulate SQL queries to return what really might be sensitive data that otherwise shouldn't have been returned from a database table. So now we know that there are a collection of different types of firewalls that we can apply to protect things like networks, individual hosts, cloud-based resources, and web applications.